For today's Journal Club, I'm really delighted to be joined by Dr. David Miller. Since completing his PhD in dental biochemistry in 1982, David has worked in academia for over 35 years on a range of models from slime molds to brine shrimps before settling on basic andrology and on sperm DNA and RNA and its packaging in the sperm nucleus. He retired from the University of Leeds in January, where he retains his title as Reader in Molecular Andrology. Today's Journal Club and David's most recent accomplishment is based upon the hyaluronan-selected study, looking at whether embryos fertilized with sperm captured by hyaluronic acid and used in ICSI procedures were better at going on to successful live births and reducing miscarriage rates than sperm selected by the embryologist alone. Alongside this was a mechanistic study aimed at finding out what was different about hyaluronan-selected sperm that may explain the clinical effects seen in this trial. David will try explaining the observed clinical outcomes and what it might mean for future treatment in this Journal Club presentation and during our Q&A session. So it's with great pleasure that I would like to introduce our Journal Club presenter, Dr. Miller, who is the lead author of this article published recently in the Lancet, which is a multi-center study that was conducted in the UK.
Thank you very much for the introduction, Steve. One thing I'll say, I've noticed my hair has grown considerably longer since that picture was taken some time ago now, I think. And I'm delighted to be able to be with you today to talk about the HABSelect trial and to give you a little bit of insight into some new results, which we will be hopefully publishing soon, but which I'd like to share with you today. So first of all, I'd like to thank the people who of course were very much involved in this study along with me here. You can see them listed here, and it's important that I acknowledge them, and I'll also be acknowledging other members a little later on. I'd also like to put up my disclosure for everybody just to have a quick look at. Show them not hiding anything. Okay, so hyaluronic acid, well, it's one of the most common molecules in the body. It's a complex glycosaminoglycan made up of glucuronic acid and N-acetyl D-muramic acid. And of course, it's an ancient molecule. It's very commonly used in moisturizing creams. And of course, it's also used in clinical medicine for things other than just sperm binding. It's used for people with arthritis, injecting into the synovial fluid, where of course it's a very important lubricant. Okay, so the objectives of HABSelect and the reason why we got into it was because there was some good evidence that hyaluronic acid could bind to, or sperm could bind to hyaluronic acid through receptors on their surface, which would only get there if the sperm were mature enough to express them. And some work had been published in the past showing that sperm which bound to it were just more mature. They had less residual cytoplasm, their DNA was better, they swam better, and so on and so forth. So we managed to get some money to really examine this more carefully and look at the efficacy of sperm selection with hyaluronic acid, and also to, as Steve was pointing out, mechanistically evaluate integrity and potential compensation for poor sperm quality. And it was a standard three-phase parallel arm. We chose Pixie not for any particular reason other than it was approved for use in the UK, and it was a system which we knew we could help with Embryo as far as training and its use was concerned. And it was something which we thought people could get a handle on relatively easily. The setting was a randomized clinical trial, of course, in up to 16 centers in the UK. We had to try and achieve 90% power to get a 5% difference in our primary outcome, which was in live births. And so 14 NHS centres, 2 private centres, and the mechanistic work, which I'm also going to talk about today, really for the first time to hopefully a large audience, was based in 3 labs. I'll come to the participants later. There's a summary there, but you can see it was a pretty big trial. The eligibility criteria were such that for inclusion, it was fairly broad. You had to be undergoing an ICSI procedure, informed consent, of course. You can see that the requirements for the female were fairly broad. And for the male, you know, any old bloke would do 18 to 55, just about, as long as he can produce freshly ejaculated sample. And the exclusion criteria, again, we very sort of commonsensical, non-ejaculated sperm couldn't use frozen, donor gametes, treatments relating to either reversal of vasectomy, cancer treatment, and so on, the last 2 years, and so on. They were also not allowed. And for those of you, I'm sure most of you are familiar with the method, but for those of you who aren't, I thought I'd just show you this slide based on from Gabor work, which shows actually a dot of the hyaluronic acid on the Pixie dish, which looks just like a standard Petri dish. You can see the sperm here, needle coming in to try and pick them, and this has been stained with a vital dye on the left-hand side to show you the cells. There's actually a difference here. You notice there's lots of cells on the periphery, which seem to be trapped at the edge, which don't light up. It's the ones really towards the middle, which are more viable, which are the ones which will be chosen for injection. And Matt Tomlinson gave me this quite nice couple of images showing a strongly binding hyaluronic acid binding sample on the left here, compared with a weakly binding sample on the right. When the sperm is stationary for long enough, those of you who know CASA well enough, it gives it a little yellow square. So there's obviously more sperm binding here than on here. And that can be measured using the hyaluronic acid, the HYDAC slide, which of course we used during the trial as well. So moving on from there, this was the trial concept, which shows you the size of the trial. I won't go through it completely. You'll have that to look at later, but you'll see that we had pretty big analysis to do, because we had, you know, and balanced, of course, looking at for Pixie and ICSI, roughly equal numbers, in fact, virtually almost equal numbers of patients. And so here are I just show you the baseline figures. These are just taken straight from the paper to show you that there were no differences really in the 2 treatment groups as far as various parameters are concerned: age, number of cigarettes smoked, and so on. This is for the male partner, and again for the female partner, there was no difference that could explain any results that we were going to get as a result of the analysis itself. And so let's go straight to the trial outcomes. Let's not beat about the bush, because you've probably all read the paper, you've probably seen it, and you probably want more, there's more interesting things to talk about, although of course they are interesting as it stands. But if you look at the primary outcome, which was term live birth, this was all done as odds ratios, really. There was nothing coming through from the primary outcome, where there was no difference. And there's nothing, secondary endpoints or secondary outcomes. Clinical pregnancy was also no different between Pixie and ICSI. The difference we got was between a miscarriage, where there was something like a 40% reduction in miscarriage rate among Pixie cohort. The other thing was fertilization rates were also slightly lower. I'll come back to that in the Pixie group. And really that's it. So on the one hand, I was disappointed in that the primary outcome was not significant, but the actual title of the HABSelect trial included reducing miscarriage outcomes, and in fact, it did actually achieve that. And this is just showing it in a slightly different way, where we have the miscarriage outcome here as being the only significantly different outcome in relation to Pixie versus ICSI. All the others were insignificant. And if you look at the primary outcome subgroup analysis, looking at the effect of maternal age, for example, all the way through to FSH, all chosen beforehand as part of the statistical analysis plan, no differences here. Although note that there was a difference with maternal age, which I'm going to come back to. This is looking at all treatment cycles, of course. But because of these wide confidence intervals here, these are 95% confidence intervals, here's the odds ratios, of course, these did not reach significance. But I'm going to come back to that in a moment. Nothing else, including the hyaluronic acid binding score here, appeared to have an effect. And again, when we realized that miscarriage was the only outcome that was significant, we then looked at this in a subgroup analysis. And again, maternal age clearly showed this effect over the age of 35, but because of the confidence intervals, it was not significant here. But again, I'm going to return to that. So the only major study that had been carried out prior to that, of course, was the study carried out in the States, the Warlow study. It was a much smaller study than ours. It looked at several outcomes, except live birth outcome. It looked at implantation rates, for example. Yellow here is treatment, and this is with hyaluronic acid selection, again, Pixie versus standard. And you can see that they only indicate whether there's a significant difference with a star, implantation rates and clinical pregnancy rates. This is all samples here, and then we go to, they stratified by hyaluronic acid binding score as part of their intention to treat, greater than 65% and less than or equal to 65% on the initial semen samples. This is the final hyaluronic acid binding score here. And they, going on to the pregnancy loss rate, they noticed that in the poor quality sperm, those are the ones with less than or equal to 65% binding, we had a significant drop in miscarriage rates. And that also applied to the final hyaluronic acid binding scores. I'll probably have a little bit more to say about that later. So essentially our results confirmed these results. It's just a pity that they didn't include live birth rates. And we also don't know much about the age of the patients involved in this study either. So now I want to talk to you really about some of the more, what I think to be even more interesting aspects of the study, the mechanistic work in the last few minutes. Because every time we carried out a treatment, the labs kindly kept sample behind for us. They'd already done the centrifugation, and this was used for ICSI or Pixie. The remaining pellets were then scored, HbA scored, and courier then sent them to the central storage unit, where they eventually came to the 3 labs, and we then carried out either Comet, Tunnel, acridine orange assay, which is a bit like the sperm chromatin structure assay, the Halo assay. We didn't manage to get around to using chromomycin A3, which measures compaction of sperm, and aniline blue assays. We also, I think that's all there is to say there. And again, the mechanistic sample was roughly 1,240 altogether. 1,247 were included in the mechanistic assay for no reason other than the time we had available, limited time. We had 4 years or thereabouts, the duration of the project. Most of that was in collecting samples, and less time was spent in actually analyzing the samples just for that reason. The time was always at a premium. And a couple of things I just wanted to show you, just that I think were interesting, is that if we look at some of the correlations, say, between sperm concentration and motility and hyaluronic acid binding, we got the correct relationship. So here's sperm concentration here. This is just all raw data. It's not been transformed in any way, which is why you see this high level of concentration here. And again, we have, with forward progressive motility, we've got the right relationship. So even though we were looking at the processed samples, after centrifugation, we still saw the correct relationships between sperm concentration and forward progressive motility in relation to hyaluronic acid binding. And again, if we look, this is just to give you some examples of looking at correlations between AO and Comet data with hyaluronic acid binding score. Again, as the DNA fragmentation measured by acridine orange falls as the hyaluronic acid binding score rises. So this is a dynamic moving average. It's not a straight line. It's a more accurate way of showing information than doing a straight line. I forgot to mention this is the confidence intervals, 95% confidence interval envelopes. And here we have the same for Comet assay. So these assays also correspond with what we intuitively thought would be correct. As HBS rises, DNA fragmentation falls. And here we have, again, sperm concentration looking with percentage DNA frag with Comet assay. Again, you can see a similar effect with it falling. And here with acridine orange. The reason why I bring these out is because these were the assays that worked best for us in HABSelect. I'll have a little bit more to say about that later. And here's the evidence that HA selection does actually give you better quality sperm. So this is a standard 95%, 45% gradient. If we take sperm from the 45, the interface between the 90 and 45, you get this kind of result. This shows you what that means in terms of better quality sperm being green and poor quality sperm being red. There's a mixture of reds and orange here. And we get roughly the same effect with hyaluronic acid. So hyaluronic acid also unbound here. You get mixtures of red, greens, and yellows, whereas you get mostly greens with bound. Okay, so here's an interesting thing, which I alluded to earlier on, that it looked as though fertilization rates have been reduced by Pixie. If we just look at the mechanistic group alone, that was clearer. And you can see here a box plot which shows that fertilization rates, these are quartiles here with median here. Fertilization rates were actually significantly reduced by Pixie. Probably due to mechanical damage during the processing, which just killed the sperm and led to a higher level of fertilization failure within the Pixie group. I know that might sound disappointing to people, but in fact, it made no difference overall because multiple embryos were created anyway. So this is just an effect which I just wanted to show you, which could perhaps be improved upon with better experience of the technique. And the age-related thing I'd like to return to, because we did a post hoc analysis when we saw that we could see clearly differences in age within the mechanistic group. We went back to the full trial cohort. This is clinical pregnancy here. And we're looking at whether or not you become pregnant depending on your age. And there's a clear, for clinical pregnant, these are only for the clinically pregnant. But there's no difference with the allocation. So Pixie and ICSI make no difference. Less than or equal to 35 or greater than or equal to 35, again, no difference. So just age overall. If we then go over to miscarriage, it became clear that miscarriage, again, based on stratifying by age, was quite important. Pixie or ICSI was also important. And, oops. And here we have the less than 35, no difference, and greater than 35, which is actually underneath the windows. So I can't see it here. But if I do that, again, an effect of Pixie and ICSI. So the post hoc analysis, to some extent, you may think contradicts the original analysis. It doesn't really. It's just the original analysis was looking at all treatments per cycle. This is just looking at the clinically pregnant. But it's an obvious no-brainer. If you just look at the paper for yourself, you can see that. Okay, so the other thing we did was to try and simply model that by looking at it by probability of miscarriage. And the thing that I think is striking about this, and some of you will have seen it already, is that this is the curve we get for age with ICSI, and this is the curve we get for age with Pixie. And you can see that Pixie essentially suppresses the curve, as we say in COVID-19 parlance. So Pixie definitely reduced the miscarriage rates that otherwise would have been seen with ICSI. And again, if we look at that in relation to percentage DNA fragmentation, this is just a different way of plotting it with confidence intervals. You can see that the DNA fragmentation rates were rising. We also saw DNA fragmentation is also involved in fertilization failure, by the way, but we don't think that the fertilization failure in this case was due to that, but was more due to mechanical damage. Okay, so I have an hypothesis that the mechanism for this age-related rescue effect of Pixie goes a bit like this. Here we've got 3 eggs, good one, less than 35, 35 to 37 years of age, greater than 37, heavily fragmented sperm, no hyaluronic acid binding. DNA can't be repaired by the egg. Remember, the sperm can't do it itself, so best avoided in any age group. Lightly fragmented DNA, weak hyaluronic acid binding, repair possible. High integrity DNA, strong binding, repair unnecessary. I think what's happening is that what we're seeing is that in younger women, they are more tolerant of poorer quality sperm than older women. And this is where hyaluronic acid comes in, because the Pixie seems to have been able to pick more better quality sperm in the ejaculate, and therefore give these women here a better chance of avoiding a miscarriage. Why it doesn't do it any earlier than that, I can't say. Why it has no effect on clinical pregnancy rates, I don't know. But we have other things to say about that, which I won't say today, but will be published in the paper in due course. So there's the summary of that. Okay, so I'm finished. I just want to thank the other people involved in the trial. These are the people who, of course, without whom we wouldn't have got any of the sperm. And they know who they are. There are plenty of them involved. And I'm absolutely grateful to them for their help. And of course, to people in Embryo for helping with the training for Pixie. Finally, I'd like to just put this slide up. After all, I didn't know Gabor particularly well, but I knew about his work. And I was very saddened to hear about his death last year, not long after I think his mother had died. I don't think there's any connection there, but a sad loss, I think, for somebody who, for me anyway, was an inspiration and gave me the go-ahead, essentially, to write the grant that eventually got this trial going, and the results you see today. Okay, I think we can go on to the question and answer. I wasn't too long, was I, Steve? No.
No, it was really worth listening to. I love the way you flatten the curve with Pixie. Beautifully demonstrated. I'd like to introduce my colleague, Dr. David Morrell. He's going to be here to help with the questions because David is an academic and not an IVF person. So I think he should be your ally in this, David. Okay.
Thank you.
So if you want to pass over to David, then to Dave, then please do. So we've had a few questions, and I think we should start really with the ones that kind of just need a bit more explanation of what the technique does. So the sort of questions that we had in that respect were, can we use Pixie in patients with severe oligoasthenoteratozoospermia? Does binding to hyaluronan select against double-stranded fragmentation breaks? And what is the DNA fragmentation index of Pixie selected sperm? And does the Pixie technique really work? So this is all really about how does Pixie work, and does it work, and what is it actually selecting for?
Well, I think, as I said in the introductory slides, the evidence is that it selects just for better quality sperm. So to some extent, that answers all those questions, insofar as they are more mature, that is, they have less residual cytoplasm, they have the receptors for hyaluronic acid on their surface, and therefore they can bind to it. And this has something to do with their ability to bind the cumulus oophoros complex, maybe then undergo hyperactivation and penetration to the oocyte. They have got better quality DNA. We found that, and as I've shown by one of the slides on there, based on the acridine orange assay and other assays, they appear to have lower levels of DNA fragmentation. Whether you could use it to treat, severely oligospermic patients, I suppose that would depend on how many sperm you were able to get from these individuals. It may well be that the hyaluronic acid binding of those sperm is still very, very compromised. It may offer no advantage. I mean, Dave might have a view on that, but again, it very much depends on a say suck it and see basis. If it's felt that it might be a benefit, then why not? David, did you have any comment?
Well, I'd agree with what you said, David. I think it's going to be confusing having lots of Davids, isn't it? The very severe oligoasthenoteratozoospermic samples, I think might technically be a challenge, because to some extent the procedure that I would advocate using relies a little bit on numbers and motility. But I think there's still a logic to placing a drop of the final sperm suspension onto a hyaluronan plaque in a Pixie dish to see if selection works. And of course, the fallback is a standard ICSI anyway, so you don't lose very much. I think technically it's just a bit more challenging, but it is feasible, I suspect.
So Dave, maybe you can deal with a couple of other questions here that's probably best dealt with you. In practical terms, for a centre with over 1,500 cycles per annum, is Pixie or Max the best method for sperm selection? And how can I deal with globozoospermia in the lab? And what can I tell the patient that has that condition?
The Max versus Pixie, I think, is an interesting one, because they're measuring different things. They're assessing different things, as I understand it. I've never used Max, but it selects out sperm with apoptotic markers in the nuclei, and there'll be some crossover, I imagine, with the sort of populations that are being selected by Pixie and deselected by Max. But I'm not sure that the two are directly comparable. Technically, they're different. The point at which you use them is different, and the endpoints are somewhat different. So it's difficult. I don't know of any studies making a comparison, so I don't think I could say much more than that. In terms of the globozoospermia, I am not aware of any reports of people using Pixie, for instance, for globozoospermic men. I think there the issue is very much around activation of the oocyte. So you'd be talking about using some sort of ionophore in combination with ICSI to maximize the chance of successful fertilization.
And David, we had one question about the morphology of the embryos, and it reminds me of one of the questions that I wanted to ask you, which was, given that density gradient centrifugation was used for 77 to 78% of the patients in your study, which actually answers another question that we've had, and is known to reduce the percentage of DNA fragmentation, do you think that, and also because 1 to 3 embryos were transferred on day 3 or day 5, is it possible that you might have observed a difference in the two groups in terms of things like the propensity of transfers on day 3 versus day 5, and in fact implantation rates between the two groups? Because if there were more than one embryo being transferred on a number of occasions, then that could be quite revealing.
So I think it's really for a future talk, a future discussion. I mean, the data is there. We don't have the cumulative rates, I think, because that would require follow-ups, which there's only a certain amount of funding which was available to work with. But all the data relating to embryo morphology is there, and it's simply a matter of getting access to it, which of course we will get eventually. It's all subject to patient confidentiality and data protection. And then we may be able to answer some of those questions. But going back to the original thing about density gradients, as you saw, density gradient does actually do a pretty good job of cleaning up, poor quality sperm. And we used mostly pelleted sperm in both for the treatment and for the DNA analysis, DNA fragmentation analysis, and yet we still saw differences. However, there's no question that we lost a lot of information by processing, which may have been present in the ejaculate beforehand. And that's one of the reasons why we've struggled a bit to get the DNA fragmentation data to tally with the clinical outcomes as well as we hoped.
Yeah, and that makes me think of another aspect of the study, which is that you did the hyaluronan binding assay on the sperm prep not on the neat, untreated ejaculate, and you didn't see any correlation between the binding assay score and the clinical outcomes. And I just wonder whether you might have seen a correlation had you looked at the score on the actual ejaculate to identify those men that maybe are going to have a higher incidence of sperm DNA fragmentation.
I think it's a fair point. I mean, we deliberately didn't go the Warlow route, which was to only really look at men who had a low hyaluronic acid binding score. We decided to be as inclusive as possible and to hopefully be able to dissect out those effects after the trial was over. But you are right in the sense that by doing density gradient centrifugation, you would be enriching for a better quality, higher hyaluronic acid binding population. Having said that, though, the relative proportions of hyaluronic acid binding scores that we got from the pellets more or less reflected what Warlow had from the initial sample before centrifugation. So there's something interesting going on there where I don't know whether they're exactly the same populations, but they certainly stratified into similar proportions, with most samples being high binding and a smaller number of samples being low binding.
And we've got another question, David, that kind of relates to what you've just mentioned in passing in terms of the cumulative live birth. So this question relates to that possibility that there may be a difference in terms of, did you look at or see any difference in embryo utilization rate? So in other words, the embryos transferred plus those that were cryopreserved between the two groups?
Again, we've not looked at that, not yet.
Okay.
Can I just chip in there, Steve,
yeah.
and just mention that the one study I can think of, Lodo Parmigiani's early study looking at hyaluronan binding, did show a higher proportion of grade 1 embryos on day 3, which you know, if that was replicated, you would expect would translate into a higher utilization rate.
Mm.
But I haven't seen any reports that specifically address utilization.
Great.
I think that's something, if I could just say, I think that's something which, you know, when we've got the data back from the PCTU, it's something where I'm going to have to put somebody in charge of looking at. I mean, David, you might want to be involved in that as well, because we've got all that data with a very large sample size, and we should look at it.
I think it would be worthwhile, for sure.
Yeah, absolutely. That would be really interesting.
And we've got another question asking whether Pixie should be used for repeated pregnancy loss, which kind of brings me to another question that I was going to ask you, which is, would you have expected to see a more significant effect upon the live birth rate had the study been tailored to poor prognosis patients, such as those of advanced maternal age and those experiencing repeated implantation failure or recurrent miscarriage, rather than simply including unselected patients, which is what you did in your study?
Well, I think I've already answered the question 2. Yes, I mean, you know, clearly, you know, the older population would benefit most from this. They also tend to be the population which suffers most of the other problems as well in relation to recurrent miscarriage and so on. So I think they're very much the two sides of the same story.
Great. I think I'm going to put this one to Dave. Is it possible that we can have 0 hyaluronan binding score in Pixie? And what should someone do in that situation?
Yeah, that's a good question. And we do get occasional reports of things like that. I think I don't ever remember seeing a 0% hyaluronan binding on HbA, so in the diagnostic test. But you have to remember that the cover slip on the HYDAC slides is very thick, so it compresses down the chamber depth so that any sperm expressing hyaluronan receptors should bind to the surface. When you do a Pixie, of course, it's actually quite feasible that sperm will swim across the surface without adequately contacting the plaque of hyaluronan to bind. So there is you certainly see a reduction in the percentage binding overall. To see zero, I think, would be fairly unusual. And if you see that, then I'd be thinking about maybe setting up a second slide to check. And I'd also be thinking, if I had it available, I'd check it against sperm slow as well.
Great. And David, we've got a couple of questions, well, a question I had, and also a question that's come up regarding age. And the question that's been asked is, in the study, what about the male age in the Pixie and Pixie groups in terms of the miscarriage analysis? Did you see anything of interest there?
So they behave, well, first of all, they behave very similarly, but that's partly because male age and female ages tend to coincide pretty well. You know, as the women were getting older, their partners were getting older too. So it's very hard to disentangle sex-dependent effects because of that. However, we do think we have seen a male effect, but much earlier on, nothing to do with miscarriage, much earlier on, probably in the transition between chemical and clinical pregnancy, which you will all be able to see when the paper itself comes out.
Okay, great. And I noticed looking at the data that according to the latest WHO criteria, the sperm concentration and progressive motility for the Pixie and Pixie groups suggests that actually on average, these were not male factor patients. And therefore, would you expect to see a less significant impact of Pixie on the live birth rate, considering that these were not what we would typically call male factor patients?
So that's an interesting point. So clearly, the study was powered to give us a 90% 90% for 5% difference. And that required us to bring in a huge number of patients to the study. And obviously, therefore, it was difficult to get a group which would have met our requirements to find a fairly weak effect, 5% fairly weak effect, efficiently. And because of that, there were a lot more younger people who came into this study than would otherwise have been the case. And in fact, at the end of the day, we had something like 60-40 split for women under the age of 35 versus women over the age of 35 in the trial. And yet, despite that, we did see, you know, a difference in miscarriage rate. So that is a pretty strong effect. Mm-hmm. So I feel that overall, we could have perhaps targeted to an older population, smaller, older population, and then we might have been able to see that conversion to a significant live birth rate that we didn't see in this particular study.
No, I think it's remarkable in such a young group of patients. So I'm going to ask Dave the last question here. Do you have any experience using sperm slow? And is it similar in its binding of sperm with similar to Pixie?
Again, a nice question. The essential principle between Pixie and sperm slow is the same in that it's a different approach, but the bottom line is that you're looking for hyaluronan binding in your sperm selection system. In sperm slow, it's a viscous medium with a high concentration of hyaluronan, and you allow sperm to swim to the hyaluronan containing viscous medium, and the sperm that bind will stick and shimmer on the spot, whereas the ones not binding will swim through. And it's a relatively easy technique to adopt. The paper I can think of, again by Lodo Parmigiani, did a direct comparison of Pixie with sperm slow and showed comparable binding rates and performance. So the fact that the underlying principle of the two techniques is the same, I guess it's not surprising that they might give similar outcomes.
Yeah.
Dave will probably disagree with me on this one. I don't actually quite agree with the mechanistic similarity between them. I think that the sperm slow is more of a viscosity shear phenomenon rather than a solid state binding that you get with Pixie. I think there is a technical difference between them.
Very interesting. Okay, it's been a great session, and but sadly we've all good things must come to an end. So thank you again, Dr. Miller, and also you, Dave, for and all the people out there. I know there's been a big number attending this webinar. All the interesting topics that you raised, we really appreciate it.
How many of them have been online, Steve?
3/4 of an hour, so that's it.
No, how many people?
Oh, well over 100. So yeah. So if we can go to the next slide, and we'll have to finish up, I'm afraid. So so as finally, as usual, the recording of this webinar will be shared with you tomorrow via email. So please also click the link in that email to provide us with your feedback for this webinar journal club. We really value your comments and encourage you to use this opportunity to let us know what you think of our webinar series. We'll also be sending each of you a certificate of attendance for this webinar in the coming week. Now, after a break next week, our webinar series continues on the 15th of June, and it regards mosaicism, reporting of live birth outcomes, chromosomes, and clinical impact. And don't forget that our website is the best place to visit to find out more information about our upcoming activities. So thank you again, everyone, for attending, and we hope to see you in the near future. And in the meantime, please keep safe and stay healthy.